Hi guys, how are you doing? I hope you guys have actually been doing great. So today actually we're going to be looking at store segmentation in the context of Shoprite, right? Please note that this can actually apply to any retail store, franchise, or anything like that. So the goal here is to say, given a data set of a specific company about its store, we want to actually group all of these stores based on specific characteristics, right? So you might imagine that like we have like a lot of stores, but obviously they're all operating differently. They all have different characteristics. So we just want to group all of these stores based on like similar characteristics, like what makes this group of store, like what makes this cluster different from another cluster. It could be that these stores are different because maybe they're selling frequently. It could be that another cluster is different because it's making a lot of money. It could be that another store, a group of stores is probably like doing poorly, something like that, right? So the goal is just to say, how about we help a business make good decision when they have to like allocate resources, right? You can imagine now like a specific retail company want to allocate like transportation, inventory, all of these things, right? They might want to prioritize all the stores which are selling at the high frequent, right? So like you can imagine these cluster of stores, they're selling like at the high rate compared to those ones which are not selling at the high rate, right? So that's when like these companies now they can prioritize those ones. Okay. Another reason it could be that maybe a company want to expand, right? Like they're looking for another opportunities. Then this data can actually help them to kind of like say, okay, these stores are making a lot of money. And it could be because of maybe in that location, there's more people, there's more population and stuff like that, right? So there's more reasons why it might be those stores that may be making a lot of money, right? So I'm just going to show you guys a machine learning technique that we're going to use and how we're going to actually solve this problem. Okay, guys? So let's jump into the code and I'll actually be explaining a lot of things. It's going to be a long session, but I promise you're going to learn a lot and I'll share all the information with you guys on GitHub. So cool. The first thing that we're going to do is to actually load all the libraries that we're going to use. So I'll say like NumPy, like it's going to help us to kind of like do numerical computing, especially if like we have, like when we're working like with numerical data. Then pandas is going to actually help us to kind of like wrangle the data, do data manipulation, data processing. Then we have some of these visualization libraries like Matplotlib, Seaborn. So you'll actually get to see how I'm using them. And I think when you see me using them, you might actually understand what's their purpose. Okay. Read two data set from Shoprite. So it's historical sales data and there's item CSV. So this is two data set and kind of like show you like given any data set, how you kind of like approach it. So the first thing that I'm going to do is to actually read in the store data set. So this is store data set. So what's going on is that like you can think of this as like we have multiple stores inside here. Like, like this is store 52. So it's a unique store. Like then this is an item that they sold and they sold it at this price. Then this actually counts how many items were sold per day for that item. Okay. Hope I'm making sense, right? Then this actually represents the date that was sold, that item was sold. Remember that this item ID, I know it can be confusing for some of you, but essentially it's just best practices. Like for any company in the data warehouse space, you're not supposed to store like data in its like raw format, like like names and stuff like that, like IDs. So you kind of like anonymize everything. So like it's just practices, I'll say. Okay. So we're gonna look at item head. So like I said, I was given two data set. The first one, it looks at the data from the store, and the second one looks at the category of the items, right? So this is like item category ID, and this is item IDs. So what you wanna do is that the pattern that I'm seeing here is that these two tables have something unique, right? Which is item ID. So we can use this item ID to actually join these two tables, right? So I'm just gonna do that now. So I'm just gonna say pd.match, which is a pandas library to join these two. And now that they're joined, the good thing is that I have one data set that I can actually work with, right? So this is my data set. We have added that item category column. Okay, so item category column, like I said, this is like a category of items, right? Like you can think of like banana, apples, they're all in one category, which is fruits, something like that, right? So that's what this column represent. Okay, so let's go to EDA. So just to kind of like cleanse the data and see how many rows we have, so we can see in this case we have over like 2.6 million rows and we have 8 columns. Okay, so it's just like these are like all the checks that I'll advise someone to do all the time. Like check for duplicates. Things like duplicates can actually like have like data leakages, like assign more weights to these duplicated rows. So it's quite important, kind of like cleanse the data and like clean it thoroughly, because if you don't do that, then like things like data leakage can happen, right? Whereby a model is doing good on the test, but when you go to production, everything is bad because you kind of like had duplicates and stuff like that, right? Data leakage. Okay, so that was just a heads up. Okay, so we're gonna look at the final store info just so that we understand the type of the columns. We can see that this is supposed to be a date, but it's actually an integer 64 shop ID. So all of these columns are integers. So we're gonna sort the types as we go along. So I'm just gonna describe the data. So the reason I'm doing this, I saw that I'm actually working with price. Based on experience, data does not come as clean, right? Sometimes you can actually get ages for, let's say you're working with data that has age, right? You can see that actually this data has like 500, something like that, right? So it's quite important to kind of like cleanse the data, like summarize it. Like for example here, what I'm doing to see if like the price is, what is the minimum value of a price? What is the mean? What is the looking at also the percentiles, something like that. So the one that I wanted to look at was the item price, mainly because I see that actually the minimum value is negative, right? We all know that you can't have a negative price, like, right? Unless if, according to me, I don't know the actual scenario, what happened, but according to me, I could say maybe it was all the returned transactions, right? So I want to understand like more into this, right? Like, okay, these were returned transactions and stuff. Okay. So if there were returned transactions, I'm expecting to see the quantity column to also have returned the product, right? If I don't see that, then I know that this is bad data. Like I will just remove this out of my data set because it's bad. Like you can't return the price, you can reverse the price, but you don't reverse the product, right? So what I'm doing here is, let's just say, take the data set and take the item count per day, because like how many items were bought per day for that row. If it's less than 0 and the item price is also less than 0, then just return yes, right? Then I'm also checking all the quantity where it's negative and stuff like that, right? So essentially what I'm doing here is just to say, I want to see how consistent this is. Like we can't return, if we can't reverse a price and we don't reverse a quantity, if like we did not reverse these two things, then that is a bad data. So I have to remove all of those rows, right? So it looks like I have to remove 2.938 rows. So see how we work with those, right? So okay, cool. So which store has negative item count per day, right? So just like sometimes, like before you remove like the bad data could have a meaning. Like sometimes it could happen that it has a meaning. So what you want to do in this case is just to like look at this, because we want to like do store segmentation based on the store. So what you want to do in this case, we want to look at the negative prices, like, against the store, because maybe this can actually help us to kind of like cluster all of these stores, because you can imagine that why is this store has negative prices? Like, it doesn't make sense. There's a fraud going, there's a fraud going on, or what's going on. Like, but it's just to say, like sometimes bad data could explain something, right? Like negative values could explain something. So don't just discard everything. Before you discard it, just like try to analyze it. And this is what we're doing here. Just gonna run this. So these are the stores that have like all the negative prices. Store 50. So I tend to like group them by all the items that have negative stores, and I ordered them so that I can see which store actually has all the highest negative prices. So we can see store 50 has more, and which store has a negative quantity is 62, right? So these are all the stores that have all the negative price and negative quantity. So I don't know what that means. So we'll dig deeper into the data. Maybe we can find out. It could be a noise, maybe it's because obviously these are large stores. So maybe we're expecting a bad data from them. So we will see as we go along. Okay. So let's see example of negative 0 rows. So there we're looking at it from analysis, but now I want to see the actual data. Like this is the data that I want to see. Okay. So actually, sorry about guys. Let me just. Okay, sorry about that, guys. I just needed to plug my computer. Okay, cool. Let's continue. So what are we gonna look at now is just to say, okay, let's cleanse the data and see where the price was 0 or was negative. Okay, so we can see that this is the situation and this is real, right? Like this is unacceptable. So this is a challenge. Why am I saying so? If negative price and quantity represent return items, then why can't we find both negative values for both price and quality on the same row? Doesn't make sense, right? So these are the type of things that you want to remove. So this code here, just going to remove all of these rows. So I'm filtering, I'm saying select everything, but not items less than 0. Like where price is less than or equals to 0, just remove it from the data. Okay, I don't need that. And I'm doing that also for item count per day. So remove it. It's bad data for me. But there are other alternatives that you can use to kind of like work around that data. You can probably use scikit-learn impute to replace missing values. If like you have like missing values, like then you can use k-nearest neighbor algorithm to replace the values, especially if it's categorical values. So yeah, those are like options that you can like devise, kind of like I said. Also, you can try to understand the data source, where the data is coming from. Okay, so we can look at the data again, and we can see that now the price does not have the mean value, does not have negative. So now we're good to go, right? So what I want to do is to join these 3 columns, like day, month, year, and create a date from this. Like I want to, because now they are represented as integers. So I want to combine all of them, and then I create a date column, something like this, right? So let's do that. So this is going to give me a date column. Okay. So like I said, guys, we have 2.6 million rows. So there's a lot of data inside here. So you can imagine like the transformation, it's not even fast, but we have a lot of data. So just bear with me here. But I will show you a technique whereby we can like compress this data as we moving towards solving machine learning, and you will see how you can now condense this like million rows into like something very small something that you can actually work with. Okay, but the goal here was just to for us to kind of like have this date column. So now we can use this like for time series to look at the data, because date could be very important. Maybe certain stores are selling more, you know, like December, it's I don't know, maybe October, I don't know, like when is the busy day, right? So but it could be very important, right? So here I'm just making that data to be a data column. So this is part of feature engineering. So if like two columns are like there's a high correlation, so think of a way you can like create one column from those two columns, right? In this case, I can create a column called amount, right? Because we have what is it? We have item price and we have quantity, so we can actually understand how much we made. What is right? So you have quantity and you have item price. So just gonna use that item count per day. Let's see. Perfect. So now we have the amount. Okay. Now let's look at the correlation, right? So why are we doing this? Like I said, like you wanna see essentially the correlation between columns. So this is a technique I see in machine learning, right? So what happened is sometimes you're gonna like want to remove correlated features, especially if like you go into like if like it was a supervised machine learning, like you doing like regression, something like that. And the second, you wanna see which columns are actually correlated with what you want to predict. Okay, like it could be the target, like let's say you wanted to predict salaries or something like that. So you want to see how correlated those columns are to the target, right? In this case, we're working with unsupervised machine learning, so we just want to see how some of these columns are correlated to one another, and especially shop ID. Okay, so this is a person correlation. But whenever you want to see correlation between categorical values, like categorical columns, you can use cheat test, right? Especially if you're going to do classification problem, whereby maybe you want to predict if a customer is going to churn, then you might have columns which are categorical, and you can do a cheat square test, kind of like see correlation between categories and stuff. Okay. Cool. So we can see the correlation between the columns. Okay. This is like how you can like interpret this. You can take item price, and you can see that actually item price is negative correlated with item category, right? Okay, and you can see that item ID, although it's not a high, I wouldn't say it's a high correlation though, 0.36, so it's not a high correlation overall. So yeah, that's how they kind of like see how correlated the item was. Okay. So now this is where things start getting interesting, right? So we wanna kind of like deep into the data and like just to try to understand the data and like which stores are making more money and stuff like that, right? Just gonna answer like a lot of cool questions. Okay. So top 5 stores by sales. Like let's look at like which stores are really like selling a lot, right? So I'm gonna share the code with you so that you can work through it. If like you want me to guys to kind of like explain or maybe teach pandas, leave a comment in the description so that I can probably teach pandas and stuff like that. But in this case, the goal is just to solve a business problem, right? So if you want to learn the basics, just let me know. Then I'll create a separate session to kind of like walk you through everything, okay? So what are we looking at here? Well, so we're looking at amount sales by store, right? So we kind of like looking at which store. So we can think of these X-axis, they're representing the shop ID. So we can see that store 62 like has a lot of sales compared to store 22 or store 2, right? So and so like this kind of like helps us to kind of like see which stores are kind of like doing well, like, and which stores are not doing well in terms of sales, right? So cool. Let's look at store 62 because it's doing well. Market share internal, like from so now we know like it's doing well, but we want to see like the internal market share, like how is it doing like overall compared to the whole entire stores. So we can see that store 62 is actually responsible for 6.2% of like the sales in Shoprite. So this is very impressive, right? That means this store is very very like in terms of sales, it contributes 6.9. So that's very huge, taking into account the number of stores which are inside the data set. So quite impressive, right? So we're gonna look now top 15 stores. So we're gonna look at top 15 stores with internal market share, right? So we group by shop ID, then we calculate the amount sum, then we sort the values, then we select the top 15, right? So cool. So we can see that the top 15, which accounts 53 sales amount. So like these top 15 out of all the stores, they are the ones which are responsible for 53% of sales, right? So very powerful. So it's nice to see like, okay, 62, 50, 108, these are the stores IDs. So we don't know. I know it can be confusing to kind of like tell you the number and like you don't understand what it means, like 62, 50 and stuff like that, okay? So we can actually look at the top 5 stores, and these top 5 actually, they are responsible for 26.8% of sales amount, right? So store like 68. So you can think of these as high performing stores. Like these stores are like doing extremely well. Like they are on top of the game. So very, very good, right? So from data analyst perspective. So we looked at the store. Can we look at the product? So we're doing the same thing. I literally copied the code from here like to here, because now like instead of like grouping by store ID, so now I want to group by the item. So I want to look at the product. Which product is actually, this product is actually doing well, right? So we can see top 10 products. So this product here with the ID, I don't know what that might be bread. But yeah, it's you can see like how well it's doing. And this product, by the way, guys, is actually accounting 7% overall of all the products. So this is a frequently bought product, right? I don't know which product is this, but yeah, it's like if in the store, that means this says Shoprite must always have this product because it's always like being frequently bought. So now we're gonna actually be looking at the frequency of like products, like because here we've been actually looking at the sales amount, right? Like we just doing like group by and sum the amount, so just to see which product like making a lot of money. But now we just want to see a product like which is bought like more frequently, right? So we're gonna just do a count, and it looks like this product here 1020949, it's actually being brought, like it's like one of those products which are bought every day on a daily basis. So it could be one of the need. And this product here, it's not necessarily brought every day, but it could be that it's very expensive, but it's making a lot of money for the company. Okay, because you can see this product here, it's 166.74. Let me look for it. Yep, So it's not even in the frequently bought items, which kind of like proves our intuition that so there are certain products which are kind of like brought every day. They're very cheap. They don't like make a lot of money, but like they're brought every day. Then there are those ones which like they're not necessarily brought every day, but they have like more profit. They make a lot of money. So just like keep that in mind. Which product are frequently brought and have sales amount? Run that. Okay, cool. What is the relationship between the top 10 item and top 10 stores, right? So we just want to see the top 10 items, like top 10 products which are brought most like frequently, and we want to see like the top 10 stores, like which are selling like every day, like they're selling at their very high speed, right? So what's the relationship? Because we want to see, the reason I'm doing this is because I want to see if like because we have done all of these analysis, I want to see like if like those stores are really selling these high performing products, like something like that. What's the relationship between these two? Okay. And so yep, it looks like most frequently items sold is 102094 by all top stores. So you see here, so this stores, which kind of like proves our intuition. So this product here, we saw it is 10209949. So it's being sold by all the stores, like all of the stores, and these stores are high performing stores, meaning that there are those stores which are selling like frequent, like they're making a lot of money, I'll say. So, and they all have this product, right? So which means that every store should definitely have this product if you want to perform high, right? So look, it looks like the item 166.7 has high sale amount for all top stores. Like this item prove our institution again. All of these performing stores like 24, 50, 62, we saw them whenever we're doing our EDA, they all have this product, right? And literally guys, I just like group by these two, and I sorted the data. So this is what I'm getting, and it looks like all of these stores kind of like have this. Interesting, right? Number of products sold per day. We can see that the item 102 is sold more in number per day. So yep, this is the product that I was talking about, because we can see that all the high performing stores are also selling it. It could be that this is a bread. Anyway, let's move on, guys. So let's have a look at category now, right? Just want to see category based on items. So we can see at item category ID, so it could be like 80. So you can see that this category is quite performing well, so you can see also item category ID. So usually, like, I feel like sometimes whenever you're doing your analysis, this is like an advice. What you should do, like whenever you kind of like doing your EDA for machine learning, try to analyze your data with like, unfortunately this is like unsupervised, but when you're doing a supervised, try to look at the data from the target. Like let's say you're doing customer churn, then you can like look at all of the features against the target. So in this case, we wanna classify the stores. So the good way of doing your EDA is to say, let's look at all of these features like categories against the store ID, right? That's how you can look at it again. So that's just a heads up, like just to kind of like give my advice then there, okay? So you can store the data. So you can do like time series analysis. Unfortunately, I couldn't do time series. It would be nice to kind of like do forecasting, But it looks like the data is actually inconsistent, guys. Like this is a bad data, right? So we can see the shop ID, this shop ID, because I just grouped by shop ID and month, and it only operated for 2 months. Like it's so I don't know, like I don't understand. Maybe it could be that this was a sample, like they didn't give us like the whole entire data, they just randomly sample the data, right? So actually I was reading about this. It's quite important, kind of like especially when you do your machine learning, to understand how you're getting your data, because it might not be the representation of the population, right? So you might be getting the data from the database, but it might not actually represent what's going on in the real world. For example, here I'm getting this shop ID and it has 2 months, like it is Feb and Jan. So I'll say this is a bad sampling, because if like you want to understand the shop, how it operates, you should like get the data from January to December, okay? Because like there's seasonalities and stuff like that, right? There's trend along the year. So there's actually quite a lot of different sampling technique. There's strata, there's random. Like you can like go deeper into these different sampling techniques, but they are very important that you understand which technique you're using, because if you kind of like randomly select the data, then it might not actually represent the data. So what you're doing whenever you deploy a machine learning model in production, it might not be accurate, okay? So like I said here, some of the stores do not operate for 12 months. This is not good for us to kind of like do time series and stuff like that, okay? So cool. So estate, let's look at how the Shoprite is doing overall. I wouldn't say this is like a realistic data. Like I feel like this was randomly sampled, but it's fine just for educational purposes. So kind of like you see the amount as per year, like how much they made and stuff like that, okay? So let's get to machine learning now, guys. We done the EDA, we done like, all of these things. So now we're gonna get to store segmentation, right? So I have a technique, because I feel like whenever I do unsupervised machine learning, I always want to explain my results. Let's say you kind of like clustering all of these stores, right? But then you can cluster them, but then you might not be able to explain what this specific cluster mean. Like let's say you have this group of clusters, but then you don't know what this cluster like represent. What are its characteristics? So for me to kind of like overcome that, I'm using the RFM model, right? Like just to look at these clusters from recency, like what is the recency status? Like how recent did they sell? The frequency, monetary value, like how much they sold, stuff like that. And yeah, that's what I'm doing. Okay, guys, now we're gonna look at recency. Okay, so recency essentially is like saying how recent did the store sell, right? So for us to kind of like get the date, the reference date, so we're gonna take our data set and take like the maximum date from that data set, and we're gonna add +1, like +1 day. And then when we're done, we take that reference date, we subtract it with like each date on each row, we subtract the reference date. So that is actually supposed to give us the days last sold, because we know that the reference date refers to the last day, like meaning if like we started selling from 2016, now it's like 2022, then you can imagine that like 2022, like date today, is going to be the reference date. Then you just have to go for each item in our historical data set and subtract that. And that is actually going to give us the days last sold. Okay. Then after we do that, we can imagine that we're going to have a lot of days last sold on each row. So we just need to group by store shop ID, like get a unique shop ID and get the minimum value of days last sold, right? That's what we're doing here. Okay. Then we rename the column now, just so that we remind ourselves that we're working with recency, RFM model. And yeah, and we'll actually plot the QQ plot to actually identify like things like the skewness, and see if like our data is following a normal distribution and stuff like that. Okay, so cool, we can see actually like the data here is not following the normal distribution. It's kind of like deviating. So there's a skewness here, there's a long tail on the right and peak on the left. So this could actually affect our model. Okay, so especially if you're working with k-means, could be sensitive to outliers and like data which is not normally distributed. Right, so just know that this is actually going to help our model be able to classify all of this stores, right? We're gonna look at the frequency. This is just to say like how frequent is the store selling. Like some of the stores might be selling like high, at the high rates, like like selling like if fast, like so to speak. So, but yeah, when we're looking at the frequency, like distribution, you can see that it's actually not bad. It is somewhat symmetric, so it does not actually deviate from the normal distribution, right? So, the skew, what is it? The skewness is also low, aligns with the diagonal and confirms symmetric. Cool. So, I've kind of like added this quantity here. I was not actually supposed to add this, but that is just to make my model robust. So actually I'm supposed to look at like three like components, like the monetary, the recency. So recency look at the time, frequency look at the item like sold, then the monetary look at the price and stuff like that, right? So the amount and stuff. So I just added the category because I'm a data scientist. I like to try different stuff. So just to see if like it can add a little bit of help there whenever we're trying to classify the stores. So I have monetary and so here we're just gonna try to see the distribution of the monetary. So monetary, like I said, we just want to understand which store is actually making a lot of money, like so in this case I'm also looking at the distribution of the data. So yeah, you can actually look at the store history DF. So what I want to do in this case is that I want to actually like normalize the data. Okay, so this is what I'm going to be doing right now. So just to take all the columns that we created, and we're gonna actually be applying the logarithmic. So just like normalize it so that it can be follow the same distribution, and we're gonna actually scale it. I think something happened. Let me see, did I run this column? Let me see what it says. So why frequent cut keyword error? Let me see. So I think it's complaining because of this. So it says, so I think I defined this as what? Okay, frequency cut. Sorry about this, guys. Just bear with me. I think I renamed the column. So it's kind of complaining. So we are applying the logarithmic, then we are applying the standard scalar. So I'll say like sometimes what happens is that if your data does not follow, is uniformly distributed, right? Does not follow a normal distribution. So you firstly like log it, then you apply you firstly like apply the logarithmic, then you apply the standardization like type of normalization techniques. It could be mean and max. uh Actually, here you can use min and max, because min and max is quite good, especially if your data is uniformly distributed. But if it's like it has a distribution on its own, then you can use standard scaler. Okay, cool. Let's continue. So what I want to do is to actually apply all the plot all the normalized data and look at it from the visualization point of view and the impact, right? So I really like this 3D plot whereby I kind of like looking at the recency, frequency, and monetary, and looking at these stores, like how close they are from one another with respective to these three features. Okay, I can see that like I'd say like there's clusters, yes, but like some of them are quite still all over the place, and you can see that there's actually quite a positive relationship between frequency and monetary. So yeah, that's what we expected, right? Like the more you frequently sell, then the more you're most likely to make a lot of money. So that's obvious, right? So okay, cool. So now we're gonna get to the meaty part. Like, the purpose of this project was to actually cluster all the stores and group them and see how unique they are, like like something like that, right? So we're gonna be using a k-means algorithm, unsupervised machine learning. So it's essentially a method of vector quantization, right? Originally from signal processing, that aims to partition an observation into k clusters in which observation belongs to a cluster with the nearest mean. So what that means is that you have all of these stores, right? Then what you need to do is that you group them, but then each store belongs to a specific cluster based on the mean, right? However, to choose the number of clusters that you must have, like the number of groups, then it could be hard because you initially don't know like how many groups can be inside the data set, right? So we use another technique called LB method. Essentially, it tries to find the optimal number of clusters in the data set, right? And I like this because it can like identify the clusters where the distortion begins to increase. So because sometimes like visualizing the data and plotting it, like just like we did on the 3D, like here, it's still hard to kind of like identify the clusters. So using the elbow method is gonna help us a lot. Okay, I'm gonna run this code. So which does the k-means algorithm and it does the elbow method. Okay. So in this case, the best case is 25. So what I also did was to actually try to plot all the features against the amount. We can see that there's actually a positive relationship between the frequency and amount log. When I look at the recency log and amount log means that it's a logarithmic of that feature. So it's a normalized version of the feature, right? So we're also looking at the frequency category. So this means that there are certain categories which are making a lot of money and there are certain categories which are making less money. So this is going to actually be predictive when not say predictive, but it will actually help our model to kind of like be able to classify these stores. Okay, so there's a technique called Silhouette. So it's also quite good. So you can like visualize your data based on these clusters and see them in real time. Like for example, here we're looking at the frequency and the amount. So if like we chose 3 clusters, you can see that, okay, there's cluster 0 there. And when we're looking at it, the same 3 clusters, when we look at them, but from the perspective of amount and recency, we can see also them from this side, right? So you can see I don't know if you guys can see, but there's some yellow dots here, some yellows, I'll say stars. So I don't think you guys can actually be able to see them, right? So yeah, the silhouette technique, very powerful, also help us to kind of like select that cluster. So I've chose 3, 5, and 7. So let's go. And so we're gonna go with 3, 5, and 7 because they're valid. They have a wide fluctuation in the size of the silhouette, right? So what we're gonna do in this case is that we wanna print everything, right? Clusters is so sorry about this, guys. I think I did not actually define the cluster. It's gonna run a while. It's gonna take a while. Okay, cool. Just gonna scroll down and I'm gonna run this code. Sorry about that, guys. So we're gonna be looking at these results. I think I'm gonna plot them here. Okay, cool. Just please note, guys, that the data set on its own has a lot of noise. So I've realized that the data set also is not accurate. So I'm not expecting to kind of like get the, I think they also mentioned that the data set has a lot of challenges inside it, right? But anyway, we chose 7, 3, 5, 7 because they have a wide fluctuation in the size of silhouette. I don't know if I'm pronouncing this correctly. Bear with me there, guys. Anyway, so what I want to do is that now we're going to explain the clusters. This is like the powerful part, guys. This is the fun part. This is the part that I like to do, right? Because we're going to look at the results and we're going to try to actually understand them, what they actually mean, right? Can see from this, okay, that, okay, when we select 3 clusters, like cluster 0 accounts for 78% of the stores. When we select 5 clusters, then we have 61% of the stores, just like that, right? So these are like percentages. If we select like, okay, there's 3, there's 5, there's 7, and how is that, like, if like we select 0, like it will represent like a large portion of the stores. That's what it means. But I'm gonna do something very, very cool, guys, which is to then explain the clusters, which is quite very cool, right? So here what we're doing is that we're looking at a difference in amount with 3 clusters. So now from business perspective, this is something that I can explain to people who want to understand my analysis, like, right? So here we're looking at this store, cluster 0, which represent all the stores that have like made a lot of money. Then cluster 1 represent all the stores that like did not make a lot of money. Similarly, cluster 2. And when we go to recency, it's different story. Cluster 1 actually represent all the stores that's sold now. So this is quite good, right? Like we want the stores that sells now, like recent now, like, right? We don't want all the stores that sold a long time ago. And we can look at the frequency. So like we said, we knew that there was a relationship between frequency and, amount. So we expected this. So cluster 0 is all the stores that are like, selling high, right? Something like that. And cluster 0 is like all the stores which are selling frequently, right? So yeah, we can also look at this from like 5 clusters. So whereby if we had 5 clusters, then we're gonna interpret them the same, right? You can see that cluster 4, interesting enough, it contain of all the stores which are selling, like they're making a lot of money, because this is like comparing all these clusters in terms of like RFM model. Okay, so this is quite useful, like from business perspective. Like I can say, okay, all the clusters, all the stores inside here, they want to make you a lot of money, and all the stores inside this cluster, no, they are not good. So, but they sell recency, meaning that they just sold now. That's the positive part of them. So, and you can look at it from the frequency part of things, right? Okay, these stores sell very frequent, something like that. So yeah, that's how like we can like interpret the whole entire results, right? So I can read my results to the Excel, back to Excel, but now with with uh um now with like the clusters. Okay, so now the insights, like you should always think of the insights, right? So like here I'm just explaining the clusters. Like cluster 0 is what we call a perfect cluster. This does brings money to Shoprite. They have high sales amount, high selling frequently, meaning they sell product very frequently. However, they do not have high recency, meaning that these stores did not sell like now, right? Like this stores are high in terms of product category, which is quite interesting. Cluster 0 has low sales amount compared to cluster 0. Cluster 1, I meant to say, sorry guys. Cluster 1 has low sales amount compared to cluster 0. This is second good cluster in terms of how recent is selling. It is frequent. So cluster 2 is very low in every component. So this is a very poor cluster. So this is a cluster of stores which are performing very bad. So there's something going on there. But like I said, this data, I think it was randomly selected. So it was not accurate. So cool. But yeah, that's how like guys, you can like do your end-to-end machine learning, unsupervised machine learning. I hope you guys enjoyed a lot. That's what I have. Yeah, I will store the code and everything into the GitHub. And yeah, thank you guys. Enjoy. Bye.